Hello everyone, I'm Hind Bourkhime, new resident of the Biostatistics and Informatics Unit of the Department of Epidemiology, Clinical Research and Community Health, Faculty of Medicine and Pharmacy of Fez, Sidi Mohammed bin Abdullah University, Morocco. Dear Masters of the Jury, I would like to thank you for your interest in our study and for having accepted to discuss it with such kindness. It is a great honor for me and a real pleasure to have the opportunity to communicate this work with you. Allow me to present my literature review on the role of deep learning in predicting Alzheimer's dementia. The deep learning is an innovative algorithm based on neural networks that has been shown to be very effective in discovering complex structures in high-dimensional data using the backpropagation algorithm. It has dramatically improved the state of the art in speech recognition, visual object recognition, object detection, and many other fields such as drug discovery and genomics. In medicine, the successful application of deep learning algorithms to routine tasks has enabled a lot of academic and commercial research, especially in neurology, where the first application of deep learning in medicine involved the analysis of imaging modalities for the detection of Alzheimer's disease and its variations. The Alzheimer's disease, which is a fatal brain disease with noticeable changes in the onset and only after years, functions as thinking, learning, memory, and basic bodily functions such as walking and swallowing are affected. Therefore, what can deep learning add to Alzheimer's predictions? In this study, we are about to review and summarize published literature on the application of deep learning in the Alzheimer's disease predictions. We used search engines and repositories such as PubMed and Scopus with advanced modality between 2016 and 2021 by composing the following equations and keywords like Alzheimer, deep learning, prediction, screening, risk, susceptibility, early diagnosis, classification, progression, prognosis, care, drug, and survival. We are still refining our study, so I tried to make our first curve using the calculated results of the above equations, especially those published on PubMed, to show the growing interest offered to this topic. Specifically, the contribution of deep learning techniques on the classification, progression, and diagnosis of Alzheimer's disease. Separating people with dementia from those without dementia might be easier by adapting deep learning techniques to patient data. To explore this further, we used the following keywords: Alzheimer, deep learning, prediction, screening, risk, susceptibility, and early diagnosis. Most of the studies we found use the case control study design, convolutional neural network as an algorithm, either simple or combined with another machine learning algorithm such as transfer learning or unsupervised types, and they adapted especially by cross-validation fault. Consider the following study, which is original research in which the authors investigated whether cognitive function can be estimated from baseline blood test data by applying a deep neural network model in order to develop a new test for cognitive impairment. Their model was able to predict cognitive function accurately. Therefore, it can be applied to mass screening tests for dementia and can furthermore be used by smartphones. This method can contribute not only to the early detection of cognitive decline, but also to the personalization of care for dementia prevention based on abnormal blood data that reflects individual risk. factors for cognitive impairment. Deep learning models can be a really useful tool for classifying the differential diagnoses and stages of Alzheimer's disease. In addition, they are able to assess an individual's cognitive decline in the prodromal stages, especially in patients with mild cognitive impairment, and then predict who will develop Alzheimer's disease and who will remain stable. To learn more, we used the following keywords: Alzheimer, deep learning, prediction, classification, progression, prognosis, and risk. Generally, the studies use the case control or cohort as a study model. Algorithms such as convolutional neural network, recurrent neural network, deep neural network, either simple or combined with another machine learning algorithm such as transfer learning or unsupervised types, and then they adapted it especially by cross-validation fault. Taking the following example, the authors developed a three-dimensional convolutional neural network using transfer learning for training to predict the conversion of mild cognitive impairment to Alzheimer's type dementia. This model produced the best performance in the field, but also avoided problems such as lack of data, high variance, and data leakage. The application of deep learning models can facilitate many epidemiological methods such as mining electronic medical records for the prediction of mortality risk in patients with Alzheimer's, which is a fatal disease. To explore this further, we used the following keywords: Alzheimer, deep learning, prediction, survival, mortality, and risk. Generally, these studies use the case control or cohort as a study design. Algorithms such as convolutional neural network, recurrent neural network, deep neural network, either simple or combined with another machine learning algorithm such as transfer learning or unsupervised types, and then they adapted especially by the cross-validation fold. Using this study as an example, the authors developed a model that can predict clinical risks such as mortality risk in patients with Alzheimer's disease simply by exploring electronic medical records. Indeed, up to now, there is no known cure for Alzheimer's disease. Therefore, deep learning is a promising tool for discovering new drugs in the future, selecting people able to participate in clinical trials, and to be candidates for early palliative care interventions, and so. There, in our study, we used keywords such as Alzheimer, deep learning, prediction, care, and drug. For having more information in that site. In the following article, authors try to show how can deep learning help to analyze medical data in disease prevention, diagnosis, patients monitoring, and development of new protocols, and assisting clinicians in dealing with voluminous data by using keywords such as Alzheimer and deep learning. Multiple deep learning applications can accurate both specificity and sensitivity regarding medical predictions, such as screening, early diagnosis, prognosis, etc., even in the absence of training of clinicians. Convolutional neural network has played an interesting role in improving neuroimaging first and then in the diagnosis of Alzheimer's disease. Since then, many varied simple and combined deep learning models have appeared in this field to largely involve all the other features. People with Alzheimer's disease may experience changes in their hearing processing in addition to the loss of their cognitive abilities. Thus, when they come to a clinic, many of their symptoms overlap with behaviors related to hearing loss. Furthermore, they may not hear the test questions or understand the test instructions. For that, adjusting your biomarkers like facial complexion and oculomotor biomarkers on deep learning applications is a promising innovative tool for improving dementia screening and care management. Including deep learning for surrounding Alzheimer's disease can be much helpful in the future for clinicians but also for the government in order to reduce its social and economic impacts. Nevertheless, these applications face many challenges such as biomedical data subject to confidentiality constraints, electronic medical records that are very heterogeneous and consist of clinical notes which can often be missing or incomplete, and other issues such as ethical and legal ones. The study showed that various fast-growing deep learning models using biomedical data could be a good server for all comprehensive Alzheimer's care in the future. Thus, there is a real need to encourage research in this context, but especially collaborations between clinicians, computer scientists, engineers, legal experts, ethicists, educators, and researchers. Finally, I should thank all of you. Thank you so much for your time.